All right, welcome to NXCAM 20-minute tech tips. Today's demonstrations on how to quickly react to design change requests using integrated CAD CAM. The demo will last approximately 20 minutes, and then we'll stay online and open up a chat window for Q&A. With that, I'd like to turn the session over to Phil Melkov, who's going to do our demonstration today. Phil?
Thank you, Aaron. Hi, my name is Phil Melkov from Siemens PLM, and today I'd like to spend 20 minutes to show you the benefits of working with integrated CAD and CAM and how to quickly react to design changes. So NX is the main product which we do all of our modeling and manufacturing within for Siemens PLM. And the manufacturing setup is the key to being able to quickly react to design changes. The assembly structure allows us to bring in fixed string geometry, part geometry, and once we have all the geometry into our manufacturing setup, we create a link to enable the workpiece simplification. And the link also gives us associativity back to the design model. So that means that the part can be a native NX part, or it can be imported from a foreign system. The behavior will be the same in terms of the associativity to the linked body. Also, when reacting to design changes, if we've already created some tool paths on a part, and halfway through the machining of this part, we discover that there's a revision to the part, we need to understand if we've over-machined any areas of the part, or if there's uncut areas that we need to take care of. So with NX CAM, we have the tools to give us the ability to analyze that. And of course, NX CAM gives us fast, reliable toolpath updates. So next slide, please, Aaron. In terms of inspecting the IPW, we have tools to give us a thickness analysis of how much material is left on the part on the IPW as compared to the design part, or the CAD model. So because we understand the differences between the two, we can actually generate weld drawings if there's over machining or gouging of the part. We understand where the over machining has taken place, and we can create a model and a drawing from that to represent that, and I'll show you all that in today's session. So I'm going to share my screen. Give me one moment, please. Okay, Aaron, can you see my screen now?
Yes, I can.
Great, thank you. So in the previous session, we talked about the manufacturing setup, and for those that you weren't with us last session, in the manufacturing setup, we were able to bring in the part geometry, which in this case is my molded part, and we created a link to that body. So if I look at the modeling history, the link here is the link to the design body. And then I simplified the design body using synchronous modeling to delete some faces. So in the assembly environment, if I was to turn on my molded part and just go to wireframe view for a second, you can see the difference between the design body and the workpiece that I'm working with here. So you can see that there's some faces that have been removed, and some holes been removed out of the part in the manufacturing setup. Also, we brought in a fixture. In this case, it was a vise to hold the component on the machine tool. And we also had the machine tool to represent the entire manufacturing setup. So now we can see the workpiece sitting on the machine and ready for machining. And then we used a machining template to create some tool paths. And I'll just very quickly show you the result of that. So I'll just step forward here, and you can see the tool moving along, simulating the tool path. So this is all done through a manufacturing setup, and it really illustrates well to the end user the machining environment that the part has to be set up in, the fixturing that's required, and that gives us the ability to check to make sure there's no collisions or interferences with the part or any fixture geometry. And we're also testing the machine limits to make sure we were within that. Okay, so that was the manufacturing setup. So today what I'd like to talk about, let me just turn off the machine tool and the device, and we'll take a look at the part in a reasonably good orientation for us here. Sorry for spinning around too much. So today what I want to talk about then is what happens if there's a design change to the part. So let's talk at first in the context where maybe you got the part indirectly from a supplier. So it wasn't modeled in your facility. You received the file, could have been an STL file or an IGES file or a parasolid body, and they phoned you up and they said, oh, Phil, we need to move this embossment over a little bit. And you're in the process of actually machining that. So what you could do in NX CAM and NX environment is you could go to the Synchronous modeling environment. So if I turned on my Synchronous modeling toolbar, I have all these tools in which I can manipulate my body. And if you recall, during our setup, we created a link to the design body, and we were able to use Synchronous modeling tools to remove faces. In fact, if I was to show the holes there by suppressing that feature, you see the holes reappear on the part. So I can do the same kind of thing. I can react very quickly to the request from the customer to say, I want to move these faces, so I'll just window select around, say, this boss. Let's say it needed to be moved over a little bit, and I can specify a vector in which to move it, and then I can simply drag the cone head here, and you see how the geometry of my model is actually changing with respect to my movement here. And I can key in a specific value here. So if I was to say OK to that, you'll notice that that embossment now has moved over that specific amount, and now I can go through the process of figuring out if I've over-machined or not, if I've already been machining this on the shop floor. So that's a Synchronous modeling type functionality to help quickly react to that design change. But more typically what would happen is that you would actually receive a new file. So here's my molded part, and if I received a new file, what I could do is I could say replace component. Then I could browse for that new component, and here I have that part in version B. So I can say OK to that, and my model will update according to the new geometry in the design. So now you notice that in my assembly tree I have mold part rev B, and what happened is that all the Synchronous modeling that I did originally on the part in terms of removing faces, they all get replayed or reapplied to that linked body, and that's the whole benefit of using this manufacturing setup. And the wave geometry linker and the Synchronous modeling, it all comes together to give us the ability to be able to react so quickly to these design changes. But then we go one step further, and that is that we can now analyze what's happening with our part. For instance, if I was to take a look at, say, the roughing operation. So let's go in and we'll do a toolpath verify on that roughing operation. And I'm going to tell the system to analyze the workpiece in terms of the previous toolpaths or the toolpaths that I've already generated on this part. This part could actually be sitting on the machine tool right now and be removing material. So this is showing me the old toolpath on the new part. And I see something's fishy going on here. So I can use this show thickness by color tool to analyze how much material I have on all the faces of the model. And the picture starts to come a little bit clearer. In fact, on the right-hand side, you'll see a color gradient scale, which turns red if I go negative. And I see that there is a portion of area on the geometry here that's red. If I click anywhere on the geometry, it tells me what the material thickness is there, where it's kind of like a cyan color. If I go to the red color, it's a negative value, and I can see, maybe I've over machined there, but I'm not quite sure. So what I could do is I'll say OK to that, and I'll tell the system to generate a model of that over machining. So if I say OK at this point, and if I hide my workpiece, there is my over machining. And this could actually be used as a weld drawing. And to help me understand how much I've over machined, what I could do is I could take that section view through that piece of over machining, and I can go in and I can actually measure the distance, say from this corner to here, and it tells me it's about 9 millimeters thick there. So I can make a decision based on, how this part is to be used. Could I weld this corner up and then remachine it, or do I have to get a new piece of material and start over again, or could I lower the part bottom and shim it up? So I can make all these decisions based on the knowledge that I've just found out by using these tools. So at this point here, I don't need this. I can delete it or hide it, and I'll bring back my workpiece. And in order to machine this part, I would have to actually regenerate the toolpath. So I simply go to my workpiece and I say generate. Now this will take a moment or two for it to regenerate all the toolpaths. And also in this area here, it looks like this pocket has gotten a little bit deeper, so there's extra material on this face which is simply machined away on the updated toolpath. So by selecting the workpiece level here and saying generate, it's going to generate each one of these operations that make up the entire machining process for this part. And within a minute or two, I'll have a completely updated toolpath, and I've now fully reacted to this engineering change, knowing a lot about this part. Whether I need to start with a new piece of material or weld it up. So let's take a look at a little bit more complex situation. So I'm going to close all parts, and I'm going to open up a mold. So this mold does the front grille of a car. Its geometry is a little more complex than the simple part I had up here, and I'm going to use the similar techniques to machine the parts in this mold as I did machining that first part in the first session, which was to use the manufacturing template. And so you'll see how that goes here, how that's applied in a more complex situation. So here I have an assembly set up here. In the assembly, I have the top level of the mold project. I have a layout area where I lay out the various components of the mold. And then I have a manufacturing folder which ties in the design data to the manufacturing. So if I look at the design data of the mold, I'll turn off the top or the cavity side, and I'll just look at the core side. So here we have the core geometry here and all the parts that make that up. In this case, we're going to talk about the machining of this part here. It's called the core block. But while we're at the assembly level, let's take a little bit of a look at what we got. So we have lifters here that lift up and push the plastic part off the mold, and there's little bosses on here that are attached to the lifter. So when I'm machining this core block, I really don't need that geometry in this part. So let's take a look at the process of doing the machining then for this core block here. So I'll expand the manufacturing setup, and in the manufacturing setup, I have the core side machining. I'll expand on that. And remember, this is an assembly structure within NX. And NX CAM is integrated into NX, so we have the ability to look at all this information while we're doing the CAM programming. So there's the core block machining. We're going to select this, and we're going to make that the displayed part. What that basically means is I'm looking now only at this level of information within the entire mold tool. And you'll see that the core block is actually included in this subassembly for machining. So that gives me the direct access to the component here. But this is the design component, and I don't have the permission to change the geometry of this design component. What I want to do then is I want to use the same techniques as I used in the last session to create the manufacturing setup. I'm now in a manufacturing setup, if you like. So the first step then was to use the wave geometry linker to associate the design body to my manufacturing setup. And at that point, I would turn off the design body. So now I'm only looking at the link body that I created in the manufacturing setup. Now, in terms of working with integrated CAD-CAM, this component was designed within NX, therefore it has a history. So what I can do is, with my wave geometry linker here, I can say edit the parameters of that, and I can use fix at current timestamp. So not only is it associative, but I can also specify at what point in time do I want to create this link. So if I look at the history of the modeling of this part, you know, there's an extrusion, there's some counterbore holes, there's a trim body. This trim body is basically the parting line of the cavity. So if I said, let's fix the timestamp at that trim body, everything that happened after that in terms of the NX design will not occur in my manufacturing model. So it really makes it easy to simplify my component for machining. I don't have to go and create surfaces to cover all the holes or slots or anything like that. It's fixed at the certain stamp in terms of modeling in time frame. I can also go ahead and use the synchronous modeling to say, let's remove the holes. So again, I can pick all the holes that are left over because they may have been done after we've created the cavity using the parting surface. So I can select those and remove those from the model as well. So now I've really simplified my, my machining surfaces. Although I still notice that I have these little embossments which are supposed to be on those lifters. So what we'll do is we'll use the synchronous modeling to delete face. So I'll say delete face, and I'll just come in here and remove those faces. I don't need those. So I'm just selecting those faces that I want to remove, and you'll notice that I'm using the lasso to select. I find the lasso gives me a lot better control over how to select all these things, and I can navigate around other geometry not selecting it because I don't want to delete those faces. So by clicking on the apply or the OK button, those faces have now been removed from my part, and I'm ready to actually start machining. So at this point, you'll notice that we're starting to see some familiar information here. We've got our linked body, deleted faces, so this is synchronous modeling, and this is our wave geometry linker. We'll start the manufacturing process now, so I'll go to manufacturing. And first thing I got to do is define my part. And this is standard procedure for all manufacturing setups. I'll use auto block to create my block for machining. And of course, we can always oversize the block if you want to by pulling the cone heads here. And we'll specify it's maybe P20 tool steel. And we're ready to go. Now in this template, I have a series of machining operations of which I'll grab some, and I'll just move them under my workpiece. And we'll go ahead and we'll generate the first one. So now that machining operation, which was previously defined by, say, a more experienced programmer than myself, and me as a new or casual user to NX CAM, I don't have to worry about all the different settings for these operations. I can just move them into my workpiece and tell the system to generate the toolpath. At that point, I can go in and I can say toolpath verify, and I can have a look at the results of that machining operation. Let's just speed that up a little bit. So you can now see that the tool is removing the geometry for that part. So we're not too interested in actually watching that happen at the moment. All we know is that that we've generated a toolpath for this part, and we're now in the process of machining it in the shop floor. So let's go back to the modeling environment, and I'm going to simulate a design change. So I'll go back to the actual top level of the mold project. So here I'm looking at the mold again, and as I described earlier, we have this layout section here. If I expand on that, I have actually a trim section. So if I make that the displayed part, so now we're focusing our attention just on the parting line for the mold. What I can do is I can say, well, I want to change the actual core cavity design here. So I'm going to use this as my new parting line. And typically in any engineering process, I'd probably have to develop that parting line, spend a little time developing that parting line. But for the purposes of this presentation, I'd already done that work. So all I have to do really is go back in the history of the parting line and reselect the new faces that I want to use as the parting line. NX has that power and capability. Although I'm not sure what's going on here. There's this deleted face thing. It's an error in the selection. I'm not sure what that's all about, but I'm sure it'll come to attention soon. So let's go back to the parent assembly. So I go back up to the project top. And I can see that there's a considerable change to the actual geometry of my core block. Right? You can see that it no longer is a tub type cavity. It's a four-cornered post. So let's go back to the manufacturing setup. So if I say make displayed part, you can see that my manufacturing parent geometry has changed to update, and all of my modeling history, the link body and the synchronous modeling has been replayed against this part. Although I see an X here on this delete face, and I see that I still have those little embossments there. So that's where that message was pointing to, in fact, that it couldn't reselect those faces during the replacement. So what I'll do is I'll just go ahead and I'll repick those. But I'm just using my mouse and the shift and control key to do that panning and zooming. All right, I also have a 3D spaceball, which allows me just to dynamically move the part as if it was sitting in my hand. Okay, so we've updated that synchronous modeling issue. We can go back to the manufacturing operations or environment. And again, we do the same thing as what we did before. I have a hot button V to go into toolpath visualization. I'll use dynamic, I use suppress animation, and I'll compare the old toolpath against my workpiece. So it'll take a moment for it to do that. Okay, and then I'll show thickness by color like I did before, and this allows me to actually measure and understand the material thickness that's left on the IPW compared to the design model. And it uses that same color scheme, right? So I can go in here, if I click on a location, it tells me that there's 3.2, I think we're working in inches here on this part. And again, we have a red area, so we have minus half an inch here. So again, I can use the section tool if I want to kind of help understand what's going on. The section tool is an amazing tool for the CAM user. It gives me the ability to display a couple of section curves. So I can say, show the section curve preview, which is what we're seeing here. and do a dynamic update while dragging, so I can really get a good clear picture of what's happening as I look at this. So this curve is actually the machined material. This curve is the design model. So you can see clearly that there's a lot of material that's been removed here. So let's cancel that section view. Let's go back to the toolpath analysis. And again, we'll go here and we'll create the over machining area. And if I hide my workpiece, I now can look at in detail the over machining of my part. And really, it's the over machining that's critical. The under machined area can simply be remachined and cut away, but the over machining means that I've cut too much material away, and I really need to look at this to understand what I need to do to repair this. So again, I can use the design tools then to go in and measure the distance, say from here to here. So that's almost 2 inches of material that I'd have to lower this block down by in order to remachine this and get a satisfactory part out of it. Otherwise, I'd have to start with a brand new block because that's too much material for welding. So again, I can go ahead and I can hide this or delete it, and I can show my workpiece. And then I go back and I simply say generate to create a updated toolpath, and I can start machining again. So hopefully that illustrates to you how easily and quickly you can react to design changes when you have an integrated CAD and CAM system such as NX. So at that point, I'll pass it